All right, hello, everybody. How's everybody doing today? All right, I'm here, everybody. I'm here. I'm here doing things. Yeah, hello. How's everybody this fine evening? Hello. Hey, Susan. I'm doing wonderful today. Today is a super positive day. I don't know why, but you know what? It's super positive today. I'm just in a really good mood here today. It's been a glorious day. Absolutely glorious. We've had a lot of wonderful people come by the stream already, and it continues to get better. This part is true. I hope you had a wonderful week there, Susan. Managed to actually shave a little last week too. I'm like, starting to grow back still. I mean, still got the 5 o'clock shadow, but you know. Change that up a bit. Hey, there we go. Perfect. You had a good week? Wonderful. That's wonderful to hear. Very good. Mazdy, how are you doing? Are you doing well? I hope so. Sorry for the little bit of the late start here today. I was talking with somebody just a bit earlier, so got that squared away. Just chilling? I like that. If we're just chilling, then I'm Plenty happy with that. Plenty happy with that. I like the fact that we can just chill and have a nice time. That's all that matters. Yeah, that's right, right? Yeah, yeah. Blap, blap, blap. Blap. Alright, that's fine. Alright, just had to check that real quick. Alright. We'll wait for a few more people to come on in, and we'll go ahead and get started here. We got some stuff we got to talk about here today. Some very important things. Very important things. Ujwal, my dude. How are you doing, my friend? Buddy, I loved listening to your track. It was wonderful. Good, good. It was really, man, you are very, very creative, I have to say. I got it actually. No problem, no problem. You can hey, keep my contribution as well. So I just hope it leads to bigger and better things, my friend. That's all that matters. You like a listen, Sam? Absolutely. I think if Ujwal's okay with that, I am cool with that. Yeah, let's have a listen. I don't disagree. All right. Let's all have a listen here together, because I have it on here. That's really good, man. That is freaking outstanding. I have it saved and everything, my dude. Like, legit. Whew. That is a banger, my friend. If you've ever been to an Indian or Pakistani wedding, bro, oh my gosh, that is a banger. No problem, Ujwal, my man. You put a lot of effort into it. I really appreciate it, my man. Hey, that's all good, my man. That's all good. Oh man, let's feel part of an action film. Legit, Sam. Look at that. You really feel it when you got such a banger like that. I'm gonna be honest with you. Natty, hello. How are you doing today? Zazana, hello. I hope you're doing well this very fine evening. We got a lot of people in the chat here that are hopefully are ready to learn a little bit here today. I think we're off to a great start. We're off to a banger already. Look at this. My goodness. My goodness. That's all I have to say about that. My goodness. Well, we're going to talk about some now I got to do the other thing. All right. Now we got to do the not so great things, but we got to do it anyway. Is let's talk about the topics we're going to be covering here today. Today we're going to be finishing up well, we got wait. Hold up a second. What am I doing with my life here? Let's do take me back to the wedding. Sounds like go back to the wedding, bro. My man, you go to Indian Pakistani wedding. You get buffet food. All right, you get free drinks. You can't go wrong. Okay, buffet food, all you can eat, all you can drink. You just have to show up and give like a card with $100 in it. I mean, it's the easiest thing ever. You just dress up a little bit, super easy. You want a free meal, you go to a wedding. It's so amazing. And you go dinner time, you got that right. You got that right. But the program can't last very long. That's the one important part there. Program lasts too long, everybody's gonna hate you. So no one ask you. That's true. That's true. Yeah, you have to come after hors d'oeuvres are served. So all right. Okay, ladies and gentlemen, let's do the intro here. Okay, let's get started today. Welcome back to Wednesday. All right, the only time we're meeting this week, so end of the week time here today. Obviously, we didn't meet on Monday due to President's Day, but today we're going to go over some wonderful bits here of more of statistics here. Now, I want to give you a little bit of a heads up here because we're going to finish up chapter 4 here today. We're going to get into a little bit of chapter 5. That's what's on the docket here for today. Now, once we finish up chapter 4 here, I am going to talk about the test. Okay, so the test. It is here. Okay, we are going to finish. Okay, the material there for the test, which will be over chapters 1 through 4. Okay, so over chapters 1 through 4. And like I said, I will be fully transparent with you about what to expect for this exam. I have just made it up this afternoon. All right, it is all set and ready to go. All I have to do is release it to the world. So, but we will talk about a lot of those details. We did discuss a lot of the details here last week, but I'll reiterate them again anyway, just so for those who missed the last stream or missed that last little bit, that is not a problem. Okay, I am here to help. All right. In any case, let's go ahead and get started here with the other part here of chapter 4. All right, so let's do it. Let's go to our main screen. Bam, I got it. All right. All right, so last time we talked about if a linear model was appropriate, we found the correlation, a coefficient of determination, pardon me, and we also found the correlation coefficient. We defined that as R and R squared. Okay, so we found those guys and we talked about exactly how well a line of best fit would fit with a scatter plot or a set of data. All right, so we talked about that in particular. Now, today we're going to talk about one more piece of very important data here. Is that sometimes, again, if we've been talking about summaries of data here back in chapter 2, when we talked about, say, frequency distributions, or again, we talked about relative frequency distributions. We're going to still stick along that front there as well. Hey, Yusuf, I'm doing really well. I hope your night's going well. Okay. So, Yusuf, I got some royal milk tea here. Royal milk tea is what I got for today, but I got the energy water in the fridge. So, yeah. All right. Tastes like victory. All right. Now, let's take a look at number 5. Number 5 says, "What is a contingency table?" Okay. So, in order to showcase a contingency table basically will be again a table of data, and probably should put that in. So this is a table of data with the rows and columns. Okay, so of course each row has a category, each column that indicates a category. With the totals of each written. Yeah, basically the totals of each written. And what I mean by each written is each column, each row. Okay. So basically, that's what the contingency table is going to be for. The totals of each written here. Again, sometimes it's written, sometimes it's not. But each contingency table, again, it'll be relates. Essentially, will relate two categories together. So let's try that. All right. So what exactly does a contingency table, pardon me, look like? Well, let's take a look here at the book, and we're going to showcase how this looks like. All right. So, oh, wait, what? Oh, okay. Why does it say eat? Okay, and I'm being dumb. All right. Okay. All right, just give me a second here, guys. For some reason, this doesn't back. Log in. Site gives me issues. Some. All right. I think it should work now. All right, there we go. All right, sorry about that. Just asked me to relog in. So page around here. Uh, Gotta have to fish around the book here a little bit. Yes, yes. I always forget that this is a bit off from my current book. All right. All right, there we are. So this is a contingency table here. Okay, so you can see these levels of education compared to your employment status. As you can see, we have rows, we got columns here. Did you finish high school? Are you a high school graduate? You have some college, you have a bachelor's or higher. Again, if you're employed, you have a level of education. You can get the general gist here about how we can relate two things here together, and of course break those down into individual categories that you can see here on screen. Okay, so this isn't it's not too hard to figure out what this looks like. There's going to be a lot of it. The reason why I'm pointing this out here specifically is because we're going to see a lot of examples that use these contingency tables because they're a great summarization of data that are just pretty easily linked together. But you could literally take a survey and then find out, okay, what's your level of education and are you working? And people could say yes, and you can slot them into a category, whatever the case may be. Right. So the question is, of course, with these contingency tables, with these examples that we're going to see that look like this, what exactly are we going to do with them? All right, so that's what the next question here on the handout is going to talk about. Let's talk about that right now. Okay, number 6. What is a marginal distribution of a variable? What is a marginal distribution of a variable? So all we're going to do here is the definition of this is just basically a frequency or relative frequency distribution of either the row or column of the contingency table. Okay, so here we have that. Let's make sure we have that formalized. All right, now let's go ahead and take a look here at said definition. What exactly does this mean? Well, let's look at the next page here and you'll see what we're talking about. Okay, so for example here, here's one example of a frequency, marginal frequency distribution. Okay, so here we could just put the totals of each column and each row here respectively in these particular spots. Okay, so you can see exactly how this works out. Either we can add up all the numbers in each column, put the totals in each one of these columns, or again we can add up the numbers in each one of these rows. We get the total in each one of these rows. And then finally, these numbers here put together, everything in the totals in here and everything in the columns over here should equal the same amount here at the end of the day, depending on how many people that we surveyed or whatever. Okay. And of course, you could do the same thing here for relative frequency marginal distributions. So instead, what do relative frequency marginal distributions look like? Well, they look something akin to this. So again, you take the total amount of people here, you again take the totals of each particular row or column, take it out of the total amount of people that you went ahead and surveyed. All right, and then you can find a percentage that goes with each one. At the end of the day, it should equal 100% because, of course, that reflects you testing over everybody here in that particular circumstance. All right, so by itself, it's not too hard to do. Again, though, probably the easiest way is just do the totals first, and then once you do the totals, you can easily find the relative frequency because all you have to do is take every single column and you divide it by the total that you have here. And you could just do that for the rows as well. It's pretty simple and straightforward. Okay, so that part there, not so bad. Okay, now I want to talk about one other thing here, and then we'll get to this other part here. So, okay, let's look at number 7, and we'll look at some examples here. So that's still on the docket here. We got to do some examples for sure. But let's do this. Okay. What is a conditional distribution? Okay, so let's talk about that. What is a conditional distribution? All right, so a conditional distribution here is slightly a bit different than that of a marginal distribution. A marginal distribution can work in both the rows and the columns here. Okay, where you find either frequency or relative frequency there. And you can see there on the screen, that's relative frequency here on the screen. You can see how that works out. Sam with the sub, buddy. Thank you so much. That is really super kind of you. Wow. Thank you, Sam. That's really, really kind of you, man. I really appreciate it. Thank you so much, my man. I hope things go well with you, Sam, and FIFA and stuff. That's really super kind. You didn't have to, my man, but much love. I appreciate that. That's I don't necessarily do this for the subs, but I do it for the love. So thank you for showing me your love. I appreciate you, my dude. Really nice guy, Sam. Everybody. Um, nah, thanks, dude. I don't know if I deserve it, but I just like I just teach classes because it's fun. It's fun, and I get to goof around for a long time. Ask everybody in the channel; they all know. Where else do I get to goof off? here. All right. Well, let's take a look here at a conditional distribution. It's true. Okay. All right. So basically, the way it works as a conditional distribution is very, very unique to contingency tables, and that basically is a distribution, a relative frequency distribution. Based on the response variable, all right, i.e., every column. Okay, so this is not going to be every row. Okay, not every row. This is just for only. Okay, let's put this way. Note only for every column. Okay, so the rows, they don't mean anything. Not for a conditional distribution. It is only the columns that actually mean a whole lot here. Daniel, I'm doing very well, my friend. I hope you're doing well as as well. Saying the same thing twice. Yes. Thank you very much, Daniel. That's really super kind of you to say. I hope you're doing well. Take care, my friend. Um so use continuous table when you have categories for a data set. Yeah, have a great night, Sam. Hey, God bless to you, man. Respect. Yeah, have a wonderful night. I use continuous tables when you have categories for a data set. Yes, so you're going to have a categories here. Again, I only care about these categories up top. All right, so let me go ahead and show it off here, Ujwal. Well, physically what this looks like. Then you'll see it makes sense here. So I'm going to go to next page here. All right, so this is a contingency table right here. So here, this is the same exact example here. Okay, only I want you to take a look very carefully. So you have to be really careful about this. Notice that none of the rows here are taken into account. The only thing we care about is all of these columns here. Okay? And if we add up all the percentages, the relative frequency of every column, they should equal 1. Now, at first, this looks a little confusing. Okay? I ain't gonna lie. You're probably saying, well, where you come up with these numbers and what does it mean? Okay? Fine. That's fair. Okay, that's fair to say. All right, I ain't gonna lie. Totally fair to say. So let's try it. Even if this example doesn't make a lot of sense because the numbers are kind of all over the place, let's take it step by step here with another example, and let's see it in actual practical action. Okay, so I'm gonna bring up another contingency table, and we're gonna work with that, so it will be a tad easier to see. I mean, this is a good example, admittingly, but sometimes it's like, okay, I don't know where you got that stuff from. So how do we work with that? Okay, so I'm gonna go to where are you? Okay, let's go with yeah, let's go with that one. Or actually, no, I could go with that one. That one's the one. So that one's the one I always do. So let's do that one. All right, so I'm gonna do question 7 here from the book. And we're going to take a look at this here carefully. I get to it. There it is. Okay. So let's take a good look at this one here. All right. So this is question 7 here. Let's go ahead and read this off. Okay. There you can see next to my head here. So I'll point to the direction that it's in. Maybe this way. Hey. No. Yeah, that way. Okay. I actually got it somewhat right. This way. No. No. This way. This way on this. Okay, yeah, somewhere. Yeah, there you go. Okay, I got it. All right, so let's do number 7. All right. Okay. Yes, there. All right. In a recent Harris poll, a random sample of adult Americans 18 years and older was asked, when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? So here are the results of the survey. they put it into age groups. Okay, so 18 to 34, 35 to 54, 45 to 54, and 55 plus. And then they have the three choices there: more, less, and neither. Okay, now there we can also see each row and column. JTS, buddy, how are you doing? Please, you can stop at any time, JTS. I hope you're doing well. I hope you're doing well, JTS. Jamal, you're always welcome at any time, buddy. All right. I've been doing very well, Jamal. Very well. See if we can answer these questions. I hope you can. Okay, so you can see here the actual totals in each column and each row. Okay, there you see the totals right there, right then and there. Now, let's say we need to make a contingency table, not contingency, a conditional table out of this. Okay, so let's say we want a conditional distribution out of this particular table. So what I'm going to look for here specifically is I'm going to look at these particular totals down here. These four totals. Yes, I know there's 2,160 people that were surveyed here. I get that. But if we're going to make a conditional distribution, the only totals that we should care about here are these totals that I've highlighted here on the screen. Now, we break out my paint tool here for just a moment, and we'll look at each one here. Where are you, paint tool? Here you are. Okay. All right. So, having this, all right, go. Hey. All right. Now, having this here, let's go ahead and make our small little table here. So the important categories is always on top. That's right, Ujwal. So the easiest way to kind of put this is and you know what? I think that's a very good note there to actually add. So let's add that here. Note let's put note number 2 here. The important categories that we use are the ones on top. Right, because we care about the 18 to 34. Now we're still going to put more or less and neither. They'll still have to be there. But the ones we only want to look at here, again, the columns here are what matter the most. So that's why I say every column here is the important one as opposed to the rows. So that's a good pickup there as well. That's correct. So to make sense of it, then I think that'll just make it easy. So we'll put more, less, and neither. I'm going to paraphrase here a bit. Let's put our age groups here. So we'll put, again, put up here 18 to 34, 35 to 44, 45 to 54, and 55 plus. Okay. Now again, the totals for the rows don't matter, but what does matter is the total that we have down here. Now, let's talk about each one here. According to our chart here, okay, so according to our chart, let's look at the first column here, 18 to 34. According to our original contingency table, we have a total of 542 people who were within the 18 to 34 category. Now, out of those 542 people in the 18 to 34 category, 238 said that they were more likely to buy something if it said, say, made in America. So, in this particular case, what would we put here for our more part? Well, for 18 to 34, that would be 238 over the 542 people who were surveyed in that particular category would be in the more category. Okay. Let's take a look at the next one down here. 22 people in the 18 to 34 category said, yeah, I'm less likely to buy, okay, if it said made in America. Right? Not a lot, but still has to be acknowledged. Right? But so we're going to have 22 out of 542 since we're looking at just the column here. Okay, so 22 out of 542. And then finally, 282 said neither more nor less. So okay, now what we're going to do here specifically is let's find the decimal equivalent to each one. Okay, so the decimal equivalent here, we're going to find the decimal equivalent. And what I would like you to do is to go out to 4 decimal places. Okay. All right, so 0.4391 is what we get here for the first one. Okay. All right. How about the next one? 22 divided by 542. Remember, I want you to round to 4 decimal places here, so make sure you round properly here. 0.0406, okay? I'm going to take your word for it here, so I trust the process and I trust you guys. All right, excellent, excellent. Okay, how about 282 out of 542? What's that going to be? 5203. Okay, good. Now, if this works out just fine, if we round it off here, we're going to get something. So if we add these 3 things together here, what do we get? What do we get when we add these 3 numbers here? Let's add each of these decimals up. What do we get when we add each of these decimals up here? 1. That's right. Nice job. All right, good. That's correct, Susan. So we should get 1 for 100%, or something akin that's close to 100% because of rounding errors and whatnot. But we should get 1 here. Absolutely right. So Susan and Beth, you both got that right. So that's our expectation. Our expectation is that at the end of the day, that should equal 1 if we're doing the contingency, the conditional distribution, pardon me, with the contingency table correctly. Now all we have to do is rinse and repeat this process here for each of the other categories, again, taking the total in each column here into account for each category. So we look at 35 to 54. We see that 329 are more likely. So we take a look here. We say, all right, say 329 out of 536. All right, we could take a look at the next one here. We have 6 out of 536. And we have 201 here out of 536. All right, and let's get some decimals for each of these. May end up moving the next column over, but that's okay. Point 6138, okay. All right. What about that next one there? 6 out of 536. 6 divided by 536. What's that going to be? 0.0112. Thank you, Natty. All right. Oh, we got 2 different answers here. We got 0165 or 0112. All right, which wait, what? Wrong one. Is it 0112? I can check here. So. Oh, oh, okay, okay. My bad. So it was 0, 1, 1, 2. Okay, okay. What is the last one here? 201 divided by 536. 0.375. Okay. Wow, directly 375. That works. All right. Good beans. All right. And let's go down the line here again. If we add it, it should be 1 or thereabouts to be 1. All right, we should keep going here. Let's finish this off here. I'm going to put the next two columns over here because I'm running out of space. Okay, so 45 to 54 here. Again, let's kind of fill this in here. So we get 360 out of 546. That's what we have here. All right. We got 22 out of 546. And you got 164 out of 546. Okay, there we are. Okay. We'll obviously get 1 for this. We'll make one more column here, by the way, for the last 55 plus. So do that. We can start filling in the blanks here. All right, so in this case here, it's going to add up to 536, as you can clearly see. So once we have that, go ahead and see here 402 for 55 plus. So 402 over 536. 16 over 536. And here we have 118 over 536. Okay, let's get some decimals here. You guys can help me out with this part here. All right, so let's go with 360 over 546. What do we get there? 360 out of 546. 0.6593. All right, excellent. Wonderful, wonderful. All right, 22 out of 546. 0.0403. Okay. All right, and 164 out of 546. 0.3004. Okay. All right. Looking good, looking good. All right. Let's look at the last three here. You have 402 over 536. 0.75. Wow, look at that. 75%. Gotta like that. Nice and clean. 16 out of 536. Sorry, that should look like a 16 there. Does not look like a 6. There, that looks like a 0.0299. Okay. Good, good. And finally, 118 over 536. 2201. Okay. All right, so we went ahead and successfully built a conditional distribution here for this particular contingency table. Okay, so that isn't too bad. As you can see here, pretty pretty easy here for this one. Okay. Any questions about this? This is again a conditional distribution. Cool. All right. Again, remember, this is a conditional distribution. Remember that a frequency distribution or a relative frequency distribution is most important. Why do we make the top columns important? Is because the definition here as well of a conditional distribution is reliant on the response variables, i.e. the y variables. Okay, so there's like the explanatory variable and then the response variable. The response variable here in this case is going to be the columns here in this particular circumstance. That's how we make up the contingency tables here. All right. Again, you could also make a, yeah, no problem. I'm here to help. All right. Remember that you can also, actually, I'll probably do that as well, but show that off in just, okay. All right. Now, I do want to point one thing out here really quick. Again, as you can see here on the screen, okay, so I just want to point things out here. As you can see here on the screen, this right here would be a frequency, um, this would be a frequency marginal distribution because you have the totals of all the rows and columns. So I'll point that out here on the screen here. Is that uh, all right, so shown is the frequency marginal distribution, as you can see here. We have the totals for all the rows and all the columns. If you want a relative frequency marginal distribution, all you need to do here is take each one of these totals and divide it by 2160, and you would basically have this. So let me go ahead and show that off here for the relative. At the very least, again, you should be aware about how to do that here for the homework. So I do want to make it I do want to make you aware about how would you do that by hand, or again, at least how you would just be able to do it. We already have all the totals here necessarily, so let's this here actually put half and half here again. So we have the total here is 2160. I'm going to go ahead and put that down. So here, for every column, let's look at every column here. We do 542 out of 2160. Whatever that is, we have 536 out of 2160, whatever that is. We have 546 out of 2160 to show why my nose is running. All right, out of 2160, and we got 536 out of 2160 here. And then if you were to do the relative part, and you can of course convert that into decimals. And then on the side here, we have 1329 out of 2160. Got 66, order 66 out of 2160. All right, and then we got 765 out of 20. Again, adding all these together here, you should just end up with one. You add these together here, so kind of section them off here. Jank, but There we go. That's generally how the relative frequency distribution is going to look like there. Again, not too hard when you put it together. All right. Are there any questions about relative frequency, marginal relative frequency, or conditional distributions? Any questions about that? Nope. Say not yet. Fair enough. I know I'm doing something right. So no. Doing something right when Natty's like, nah, not yet. Wink, nudge, nudge, wink, wink. I'm like, okay, that's fair. I get it. Okay. Okay. All right. Let's take a look here at the last question of this handout. Okay, so the last question in the handout here says, what is Simpson's paradox? Okay. Um, Simpson's paradox is not the reason why the Simpsons predict everything. That is not it. But instead, Simpson's paradox in statistics is basically going to be is when it's when we a situation in which two variables have an association with each other dissolves or goes away with the introduction of a third or new variable. Okay, so for example here, if you you're about to say that. So for example here, if you have two things that are very closely related, but then suddenly a third and unexpected variable kind of interjects somewhere inside and then dissolves the relationship in its entirety, that's what we call a Simpson's paradox. Again, certain logical fallacies could arise because a third variable just happens to enter the fray. So, you know, if we talk about, say, um, let's say for example we have fuel mileage in a car. So let's say your car has a particular fuel mileage that's associated with it. Okay, maybe there's a certain amount of weight and there's a certain amount of fuel mileage because the heavier a car is, the more fuel it has to consume. Let's say your car is light. Well, then suddenly, let's say you add more weight in your car. Maybe you have people that are in your car. Well, it's going to require more. It's going to, because of the introduction of the people, which would be the third variable, suddenly that relationship of being lighter and having more fuel consumption, it kind of starts to go away a little bit. It kind of starts to dissolve and starts to go the other direction. So um, that can certainly happen in those situations. Or maybe it just destroys the relationship entirely. That's entirely plausible. So if you find a link between, um, let's say, cancer and smoking. Okay, so you'd say, well, smoking causes cancer, like lung cancer. Like, okay, that's fair. There's enough studies to show that. But maybe you introduce a third variable. It's like suddenly, if you drink a bunch of coffee, you can suddenly figure out, oh, okay, now you don't get lung cancer because you drink coffee. Now, I'm not saying that's true. Of course not. Okay, that's ridiculous. But still, um, maybe that's that third thing that suddenly destroys that notion altogether when you happen to introduce that. And then suddenly you come out with a report that says, "Oh, look, coffee reduces lung cancer." It's like, all right, oh, here we qualify it by blah 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 blah. So you could do a statistical study about that and find out like that. So just wanted to point that out there. That's certainly plausible. Okay, so that is going to be the end of chapter 4. That is the end of chapter 4. Okay. Okay, so now what we're going to do here is we're going to take a little bit of time here and we're going to talk about the exam. Okay, so let's talk about the exam in all of its glorious details. I know that everybody's been looking forward to talking about the exam um, since forever. Yeah, yeah. I know. Just like, oh man, really? Really? Let me put up my hands. It's so evil. I have to do it then. Okay. No, in all seriousness, though, we're gonna actually do that here. All right. Switch to my facial screen here. Okay, so I'm gonna just quickly prep up this stuff here off screen. Couple of key pieces of information. Okay, there we are. All right. Go ahead and show off this. Go ahead and show off this guy here. And now switch the screen here over to my no face screen. Bam. All right. There we go. There. Now I'm going to take. Let's take a look here at what we can see. Okay, so I'm just going to show this off here. This is my screen here on my MATLAB. Okay. Now, for the sake of transparency, I'm going to show you everything that I have planned pretty much for this exam. Like I said before, I'm always about the transparency. I always want to show you what's going on pretty much detail by detail. Again, hopefully by the end of this explanation, this will take away the anxiety that you may have about the exam. I know exams are no bueno, they're not fun. But if I show you the expectations for the exam here, it's not going to be as bad as you think. Okay, first and foremost here, I want you to take a look here at we have two guys here. We have the practice test and we have the chapter test. Now, we have the actual test. Now, the due date here for these exams, and I will post this on D2L here either today or tomorrow, will be next Sunday is the due date. So next Sunday at 11:59 is when this is due. So you have until the end of the week, next week of which to finish. Now, let's talk about the details behind this exam, though. First and foremost, because this is an exam, all the due dates here for everything from chapters 1 to 4 are going to be due on the 28th as well. Okay? So, what I'm going to do right now is change the due dates here for all the assignments from chapters 1 to 4. You're going to see me do this in action. All right? Right as I do it. That's perfectly fine. This is all I have to do. Make a bunch of clicky clicks. And I clicky click things. And magic happens. All right. So all of this will be due next Sunday. Right, so I'm just changing those due dates over. And then I update the changes here once I got that. And there we go. All right, so all the homework there has now been changed over through the 28th from only chapters 1 to 4. Okay, I want to do that in front of you so that way you can see that in action. It has been done. Now, the other thing I wanted to showcase here, though, is the test itself. Of course, now I've effectively changed the homework here. Let's talk about the test here. Now, the first thing I'm going to show off here is going to be the practice test. All right, now the practice test is actually fairly important. Now, you're probably saying, why? Well, the practice test is allowing you to get comfortable with the formatting of the exam. Again, the formatting for the exam here, at least the questions, are questions that you've seen there on the homework. So the practice exam here, what I have intentionally done is I went ahead, for the practice exam anyway, to edit mode here, is I put in 30 questions. Okay. I put in 30 questions, and these 30 questions are going to be the same exact 30 questions with different numbers for the exam. That's what it is. There you go. 30 questions, 30 questions. It's as simple as that, ladies and gentlemen. Now, of course, this will be open until, of course, when the test is due. For the practice exam, there are no amount of attempts you get. You don't have to worry about that. You could do the save for later option, so meaning to say you can progress and then log off and progress and then log off. You'll just have to do it one at a time. There's no time limit for these tests here, for the practice test anyway. And I've given you all the learning aids available for the practice test, so if you need to do like a help me solve this, view an example, a video, a stat crunch, or whatever, then you got that, and then that's okay. All right, fine. Okay, so I'm going to save and assign that. Now, as I said here before, the exam is exactly the practice test. The only difference is that I put in the time limit, I put in the amount of attempts, and then I basically took off some learning aids. So let me showcase that right now. Okay. So basically, I have 5 attempts for this exam. 5. All right. The amount of time you get per attempt is 600 minutes. Okay, literally 10 hours. All right. There is also a save for later option that you can see here, which basically, again, you can go ahead and try a question, you can log off, you can come back and start with that question again, and then continue to progress forward. So if you need to come back and do stuff again, that's perfectly fine. Go ahead and make that happen. All right. So that is not a problem. Again, I do give StatCrunch here as a learning aid. So StatCrunch here if you need to do anything on that, although you should probably be using the calculator because it'll be 70 times easier. All right. And then after you are done with the exam, you can go ahead and review your results there and hopefully use those results to improve your score the next time around, should you want to do so. So again, it's sitting there and waiting for you. It will be set. I will hit the save and assign button as you can clearly see here. And there you go. It is now available to all of you here starting from right now. So again, once we're done with class, if you want to start right away, you can. If you want to wait on it, that's fine. Whatever you like to do. But I've taken most of this pressure off here. Again, you have plenty of time here of which to finish. Also, regarding the timer here, a common question I get about the timer is, does the timer continue even if you logged off? The answer is no. The timer will only restart after you log back in. So it will stop once you log off, and then it will start again once you log back in. So, so you don't have to worry about that there. Yes. So that is the exam in general. All right, covers everything from chapters 1 to 4. I pretty much took a question from most section there. Will the practice test be graded? So Beth, the practice test will be graded, of course. I may see feedback about that, but that's there to pretty much help you to see where you stand and to get you more comfortable with the types of questions that you'll see on the exam, pretty much verbatim outside of the numbers. So you can get a good guide about how you can approach every single problem there and get good practice in. I think that's going to be more than fair. At least I hope so. So I hope that answers that question there, Beth. Sounds good. All right, very good. Does anybody else have any other questions here? Feel free to ask me about whatever for the exam. Yes, Jenna. Yes. I hope that took a lot of I hope that took a lot of anxiety out of the way there, Jenna. Legitimately, I really do hope that that really helped out. So explain it clearly. Good. Well, I'll try and make this as clear as possible. Back to my face. But Feel really good about this test? Oh, great, Camera. I'm really happy to hear that, man. That's exactly what I was hoping for here. Again, give a little boost of confidence here. Basically, everything's due the 28th. That's right. So you've had plenty of time of which to finish the homework. So shouldn't be any excuses for 11 days of which to not do the homework there. So homework's been open again, as I stated there in the syllabus. Again, homework is due the day of the corresponding test. So I'll make that due the day of the corresponding test. Hey. So obviously the new sections won't be applicable to that. So anything after chapter 4, like chapter 5 and beyond, don't apply, obviously. That's why I wanted to show you that I'm changing the due dates in front of you for only those sections. Anything else? Any other questions here regarding said examerino? All right. By the way, everybody, I will be posting this on D2L, and I'll be sending out an email as well to give everyone a friendly reminder. So no worries. All right. So we'll you will have that available to you. Just as friendly reminders there. Be like, hey, I gotta finish that stuff. Okay, that's fair. Absolutely 100% true. Look at that. Very nice. Ooh, that that done so. If we have questions on the practice test, can we ask? Yes, you can, Natty. Of course you can. Of course. You're more than welcome to ask questions. Absolutely. Because the numbers won't be exactly the same. So may need to make some adjustments there, but it won't be so bad. Yeah, that's fine. Obviously, I can't tell you the answer to your real question, but hey. I'm sorry, Natty. I can't go that far. I can go far. It's not that far. There's lines. There's lines, Natty. Lines that we cannot cross. Okay. For academics things. Okay. Why is it so dry in my house? All right. All right. Well. Oh wow, we've been about it for an hour. All right. So let's take a short break. We'll take a 10-minute break here. We're gonna come back at 7:15. So 7:15, we'll restart here. 7:15 restart here. We're gonna get started here with chapter 5. We'll do a little bit of chapter 5, but we're not gonna do a whole ton here. But we're in good shape here for what we need to be doing. So 7:15 restart here. Let's get it done. All right. Let's do a restart here. Oh no, JD. Don't ruin me, my man. Finish the horse, JD. Oh my gosh. That can't be good. Oh no. The horse will live in infamy. It's good. It better be better than my horse. What's your Okay. Do what you gotta do, JD. I ain't gonna stop you. Do you, my man. I'm not gonna stop you. If I have to be pointed at and laughed at, that's not a problem. Alright, section 4-1. Alright, let me go here. Alright, which question here, Natty? Question 5? Okay. Absolutely. Alright. Take a good look at this one together, okay? The last part, okay? So, when I asked about the... Oh, snap. Okay. That actually have... Okay. Okay, we can... I guess we'll roll with that. What's the data set here? 2448, 610, 612, 718. Okay. So probably D. Alright. Alright, so you did the first few parts here. Alright. I'm just gonna try and get to that last part there really quick, so give me a second. Alright, so this case I got here. Alright, let's see what we got. 918. Okay. Alright. Oh, come here. Hello. Alright, so the last part here says because the correlation coefficient is positive, okay, and the absolute value of the correlation coefficient is... Oh, okay. 0.918. Alright. Okay. So, this is not... Man. Not something I really wanted to do. I know the answer to this question here, Natty. That's really not the problem here. It's just not something that I talked about necessarily. So, which I can understand why you'd be upset about that, which is valid. Okay. Okay. So when we look at the critical values table, so the critical values associate the sample size with a particular critical value. Think of a critical value this way, Natty, as a threshold of what we use for comparison purposes. So notice in this case here, there is 1, 2, 3, 4, 5. There are 5 points here on this scatter plot. So n here would be equal to 5. So if n equals 5, then we have 0.878 as our critical value here, according to this critical values table. So 0.878 is what we get here. So 0.918, when we got for our correlation coefficient, is greater than 0.878. So what you can do is one of the things we can talk about is that the critical value here, since it's greater than the critical value, that means a positive linear relation exists between x and y, right? So let me check that there. All right, so that's correct. All right, so one of the things we use is we use a critical value as a reference value. Now, I'm not going to talk a ton about critical values here in this course. I'm going to talk about it at certain parts here, but this wasn't one of the parts I actually wanted to talk about critical values here. So I may actually just end up striking the question here as a result. But to answer your question there, I can see why that could be a little frustrating to do, since I didn't really talk about it at all. So to be fair, you're not wrong in feeling that way. Actually, I am gonna. Yeah, that's correct. Yes. Now, let me ask this question here. I'll leave it up to you, Natty. Do you want me to strike the question? I can do that. Oh, is there? Okay. Let me check. So 5 and 6, right? Check 7. No, that's fine. Oh, you actually need that one. Okay. Okay, I'll strike 5 and 6. The others you may need it, so there's some critical values in those tables, but that's basically what you're kind of doing there. Actually, let me check that. Oh, what happened here? Oh, there it is. Check that out for a second. Did I miss that altogether? Let me check. Let me check that. I just missed that altogether? I might have just missed it altogether. Oh my gosh. Wow. Holy smokes. Okay. Alright. That's actually pretty important. Oh, okay. Alright. Yeah. Alright. Okay. Actually pretty important. Okay. Okay. Yeah. Uh-ohs is correctos. I need to check that. Oh, shoot. Okay. Alright. Yeah. Alright. Okay. Okay. That's what happened there. Okay. I understand. Alright. Alright, let me go ahead and restart class here for just a few moments. Alright. So Natty brought up a question here from section 4.1 regarding the critical values with a particular table and whatnot, and the number of. So I'm actually this one here I am going to talk about here because for whatever reason I'm looking back through my notes and you see up here on the screen I totally just skipped it. Oh my gosh, how did I manage to do that? Okay, this is completely my fault and I take full responsibility for this. But it is important nonetheless. So I do need to talk about this question here because for some reason I have just completely forgot about it. So I do apologize about this. This is on me, regardless of what anyone else says. Okay. I still need to talk about number 6 here from the section 4.1 4.2 handout there. So I'm gonna wait for people to kind of grab onto that handout there. So the section 4.1 and 4.2 handout, question 6. I accidentally skipped this question. All right, I did talk about R here, but I forgot to talk about what you need to do with it. So uh, I did part of it, but I didn't do all of it, which is kind of a that's kind of a problem. Yes. Okay. So let's take a good look here at this question, and then I'll do an example here from the homework that I just did with Natty here. So that way you can make a little bit more sense of this. All right, so I'll spend a little time on this because I want to make sure that all our I's are dotted and our T's are crossed. Okay, so how do we determine if a linear relationship exists between two variables using the linear correlation coefficient? Now, in this case here, what I should have said back then is I should have gone through the steps here. So we do have to use the calculator to find R here. That part is still true, all right? But we do, once we find out what that R is, that correlation coefficient, we do have to go through 3 steps here. So let's talk about those 3 steps. Step 1, we have to find the absolute value of the correlation coefficient, R. Okay, so that's step 1. You have to find the absolute value of the correlation coefficient of R. All right. So that is step number 1. You guys can hate me later. I apologize. Um, step number 2. Step number 2 says basically what we have to do is we have to find a critical value, and this critical value here is going to be used for comparison purposes. We're going to find a critical value that directly associates with the sample size using the online appendix A, or the table given in the problem on the homework. So what you need to do here is this critical value here. What's most important about what I've written here is that here in step 2 specifically is that the critical value directly associates with the sample size. So if we have 5 points, then n is going to be equal to 5. Okay, so or if we have 10 points, then n is going to equal to 10, and there'll be a particular critical value that's associated with that particular sample size. So pretty much you'll see that in the table there. And we're just using it as a reference value here for what we're going to be doing next, which is to determine the linear relation existing between two variables. So step 3 says if 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 the result of step 1 is greater than the critical value, found in step 2. So I guess I'll put it this way here, correlation coefficient. So we'll put result of step 1 here, greater than the critical value found in step 2. Then a linear relation exists between the two variables. Otherwise, a linear relation if I could spell relation, that'd be great. Does not exist. Okay. All right. So step 1, we find the absolute value of the correlation coefficient R. Step 2, find the critical value that directly associates with the sample size using the online appendix A or the given table in the problem on the homework. And step 3, if the result of step 1 is greater than the critical value here found in step 2, then a linear relation will exist here between the two variables. Otherwise, there's going to be no linear relation in that regard. Oh man, I can't believe I accidentally skipped that one. Really bad of me. All right. In any case, let's go ahead and take a look here at an example problem here from the homework itself, and let's see this in action, okay? Wait, what happened? Just saw it a second ago, and then it popped up. Hey? Hello? Hello? Earth? 2. Okay, here we go. Okay. So this is question 6. Let's go over question 6 here, and let's talk about it, and let's do this together. Okay. So, all right. Okay, so first of all, it says draw a scatter diagram, compute the correlation coefficient, and determine whether there's a linear relation between x and y. Let's look at the data set here. And so here are some points: 2, 8, 6, 2, 6, 6, 7, 9, and 9, 5. All right, so you can determine where all those values are located. You just have to, you can plot them on a graph. If you want to copy the table, you can. That's perfectly fine. We're going to probably do that here. What do we get here? 2, 8. It's not this. That's not this. That's 2, 8 there. 6, 2. Got it all over the place here. 2, 6, 6. Okay. And what do we have here? 7, 9. All right, so that's not it. That's it. So we're going to pick letter D here as our scatter plot. Check that. That's okay. Okay. Now we're going to go ahead and use the calculator here. Go ahead and find the correlation coefficient. So you can use your calculator here. Let's put this in our calculator, this problem. So let me take away my face for this one. Okay. Go ahead and edit. Go ahead and hit the stat key. Hit the edit our lists here. Hit the clear key and enter. Okay. So we'll put in this small list. We got 2, 6, 6, 7, and 9. We have 8, 2, 6, 9, and 5. Okay. We want to go ahead and hit second and mode, right? To quit. Want to go and hit the stat key here. Go over to calc. I'm going to go down to linreg ax plus b. Okay. We should have our x list be list 1, our y list be list 2, so L1 comma L2 if you want to put that in the old manual way. Hit calculate. Okay, and here we can see our R. Our R here is negative 0.286. Okay, so negative 0.286 here is going to be our R here. All right, so we'll check that and that should be okay. All right, perfect. Now, let's look at this last part here, and we'll discuss in relation to the answers that we just got here, or at least the steps that I've just written up here. So here for just a second. So step 1, we find the absolute value of the correlation coefficient R. So in this case here, the absolute value is positive 0.286. Okay, so if we take the absolute value, just makes everything positive, so that's going to be 0.286. All right. The correlation coefficient is negative because we got a negative value there. All right. So the question is, what is the critical value here? Now, in this instance, if we look at the data set here, there is 1, 2, 3, 4, 5 data points in this data set. And because there are 5 data points in this data set, all right, specifically, then what that means is that we have to go ahead and take a look at our critical value here. You notice that we have n here, which talks about our sample size and a critical value associated with that sample size. Since we have 5 values or 5 data points in our data set, our critical value here will be 8.878. Okay. So we're going to put in our critical value here, which is 0.878. So now we make the comparison here. We found our critical value, and all we have to do is make our comparison. Is 0.286 bigger than 0.878? So is 0.286 greater than 0.878? Go ahead and pop a. What do you guys is that true? Yes or no? No, right? That is not. So, since this is not greater, then that means that there is no linear relation that exists between x and y, right? So we have to answer that question first in step 3. We say, okay, is that true? If it is not true, then there is no linear relation. If it was true, I would say there would be a negative relationship, okay, because it was started off to be a negative r value. So one of those two had to be true, but unfortunately, that did not work out to be in this case. Okay. Okay, now I wanted to explain that very carefully, and I do apologize for accidentally skipping over that question. That's not a habit that I make here, but it is a problem that it is a question here that definitely applies to several problems in that section. So I thank you, Natty, for bringing that to my attention. Um, I feel bad that I accidentally skipped that question. That's not something I do. So, um, but again, there you go. That's how we go ahead and tackle those kind of problems. are there any questions about that? Yeah, but you guys expect better though. You know, I'm not I'm not in the habit of skipping questions and leaving you in the dark about things. So I do apologize. All right, Susanna. So let me show you here. I know exactly what's going on. So when you use WinReg, you don't get R values here. So you need to set up your calculator here appropriately. So follow me here for just a second on the calculator, okay? Because you need to set up your calculator, and you only need to do this one time, okay, Susanna? All right. If you have to swap your batteries or do a hard reset, then you will need to do it again. But typically that doesn't happen. So what you need to do here is you need to hit the second key and the 0 key. So hit the second key and the 0 key. So you'll get to your catalog in your calculator. What you need to do next here, Zuzana, is to go all the way down to the D section here of your guy, and you want to go to this option right here that says diagnostic on. Right? So I want you to go to diagnostic on and hit enter, and then hit enter again. And so you should see exactly what you see on my screen is you see diagnostic on and the word done once you go ahead and hit enter twice. Let me know once you have that there. Okay, now I want you to try linreg again. All right. So try linreg again, and you should see the R values now pop up. The calculator doesn't turn them on by default, so we actually have to make the adjustment ourselves. You only need to do this once, though, unless you hard reset your calculator. All right, very good. Very good. No problem. That's what I'm here to do. Are there any other questions there? I hope I'm glad I acknowledged that first question there, Natty. Thank you for bringing that up. That was very good. Any other questions about homework or the like here? So I was gonna do no problem. Oh, cool. I was gonna do starting chapter 5 here, but I think I just don't have the time to start chapter 5 right now. So if you guys got other questions here you want to ask, you guys can ask that now if you like. I can always start chapter 5 on next week. So yeah, just ask. Look, if you're confused about something, just ask. That's what I'm here to do. I'm here to help you. So I'm not here to make fun of you. I'm just here to be like, hey, let's try and work things out. Okay. We're here to improve. We're here to learn. So nah, no problem. Thanks for giving me the heads up. I'm I'm still kind of like I'm still in shock that I accidentally went just skipped it altogether. I feel wow. I was just like, wow, holy moly, crazy. How did I miss that? All right, stuff. Any more questions you guys have? Any more questions? Otherwise, I can end off early here today. If because I'm just going to be out of time here to go over the start of chapter 5, so we'll just start fresh with chapter 5 on Monday. Will there be a review week or just all chapter 5? Jenna, it'll just be chapter 5. We're just going to start the new stuff there on Monday. We're just going to keep plodding along here. But if you do have questions there, I do have office hours there from 2 to 6. So if you want to, or you can always email me for questions. So there's always room for questions, of course. Again, if you there's a I know there's a lot of different things. The practice test, excuse me, the practice test should give you a good idea about not even a good idea. It's exactly the questions that'll be on the exam. Let's be honest here. So and I gave you like every resource on the practice test to kind of guide you through those problems there. But if you have questions outside of that, you're like, hey, I don't know what it expects me, like what Natty asked, like I don't know what these questions expect from me or whatever. Hey, yeah, then of course email me or just ask me on Monday or whatever. That's perfectly cool. So, sounds good. Wonderful. Oh, what? Okay. Any more questions? I mean, you can do some more homework. See, nobody can complain. Not for now? Okay. Well, I mean, to be fair, yeah, that's kind of true. Yeah, I know what you meant there, Natty. That's fair. That's fair. All right. Good for now? Wonderful, Beth. All right. So, I want to thank everyone. Everyone! I want to thank everybody who came out today. You all are absolutely wonderful people. I can't thank you enough. You guys make this probably the best thing that I do every single day. All right. I love teaching. I love you guys. You guys make this absolutely outstanding. All right. I wish you good luck for the test there. Obviously, that's due next Sunday, so you could take your time, relax. All right. Try that practice test out first. If we have more questions, then feel free to bring them back on Monday. We're going to start a bit on chapter 5, and we're going to continue working our way forward. We are on the path to victory, ladies and gentlemen. All right. We're going to get through this semester and get through this virus here together. All right. I'm going to check that horse out. Yes. All right, let me check this horse out. I don't disagree with you. Susanna, have a great night. You take care of yourself. Susan, you have a great night. Thank you very much. Camera, have a wonderful weekend. All right, thank you for being a wonderful student. All right, Ujwal, thank you so much for the music. You are the best. Jenna, thank you so much. You have a wonderful weekend. You guys, stay safe. Stay safe. Stay sane. All right, stay healthy. In any one of those orders. Okay. Have a great one. Good night, everybody. Good night. All right, JD. I got one for you. I'm gonna look at this. I'm gonna look at this thing. Pallid, you have yourself a great one, my friend. Oh, that's legit, Ujwal. Send that over once you got it, buddy. I'll be more than happy to play it. All right, I'm really worried. Heck yes! Approved. Now, I'm a little worried here, JD. I'm going to switch over. Oh, no, I got to switch over to that screen. Okay, hang on. There we go. Okay. Let's take a look here. Let's take a look here. If you know, you know. Nah. It even says nay. Now see, your drawing is so much superior to mine. Look at that, I can't compare. I can't even compare. Holy moly. That horse looks significantly 10,000 times better than what I'll ever put out. Oh my goodness. You're gonna kill me here, JD. Nay, indeed. Oh, my friend, you're gonna kill me here. Oh, that's a great way to end the night. Let's make a comparison between those two things. Whew. My goodness. Oh my goodness. Thanks very much, JD. I appreciate that. You're too kind. You're too kind. All right. Thanks very much, JD. I'm gonna leave it off here for the night. I think we're in good shape. Oh, I didn't mean to do that. Hey, you have a wonderful night. You have a wonderful weekend, okay? You have a wonderful weekend there, JD. I appreciate you so much. All right. I hope you have a great weekend, and I hope to see you next week. Okay. All right. Everybody, take care of yourselves. We're gonna see you next week. Nice horse. Let me tell you, well, that's as much as you're gonna get out of me drawing ever. Have a wonderful night, everybody. Have a wonderful weekend. We will see you again soon, okay, on Monday. Monday for another class here. All right. Take care, everybody. We'll see you later. All right. Bye.